My name is Olivia Lopez, and today we're going to be talking about finding derivatives using the power rule. There's a couple sections that we're going to go through. The first of which is being what is the power rule and how do we use it. The second of which is we're going to look at a couple situations where we need to use the power rule to find the derivative. However, it might not be readily apparent that the power rule is what we need to use. And then we're going to go through some examples to make sure that we understand how to apply the power rule. So let's begin with what is the power rule. So first of all, we need to know that this only applies when n is a non-zero real number. So if we're looking to find the derivative of f of x is equal to x to the n, then f prime of x, or the derivative of f of x, is equal to nx to the n minus 1. It's also important to note that there are scenarios where we will use the power rule. However, it doesn't automatically look like that when we're first given the function. For example, it could look like 1 over x to the a, but we use the power rule because that is equal to x to the negative a. This is also the case where we have something like the square root of x to the a, which is really equal to x to the a over b. In both of these scenarios, you would simplify and then use the power rule to find the derivative of the function. So let's start going through some examples. I have written up here for reference the power rule and two scenarios in which we do use the power rule to solve, even though it doesn't look like it at first glance. So let's begin. The first example, we're going to find the derivative of f of x is equal to x to the 72nd. While the 72 is a large number and it may seem intimidating, it actually is quite easy to solve this function. So to find the derivative, we're going to do f prime of x is equal to 72x. Remember, we bring that 72 in front of the x like we see up here, to 72 minus 1. And then we'll go ahead and simplify that to say that f prime of x is equal to 72x to the 71st. Let's look at another example where we have to find the derivative of f of x is equal to 4 root x to the 7th power. So in order to do that, this is one of the scenarios that we're going to apply this rule here. So what we do is first simplify it. So f prime of x is equal to x to the 7 over 4. See how we moved 4 as b and put it on the denominator of the fraction, and 7 as the numerator of the fraction as a. So now to find the derivative of that, what we're going to do is f prime of x is equal to 7/4 x. Remember, we bring the exponent down in front of the x, and then we'll have the exponent now be 7/4 minus 1. In this case, we can also write 1 as 4 over 4 to make it easier and less confusing when we are simplifying this now. So to simplify, f prime of x is equal to 7/4 x to the 3/4. So our third example, we're going to be looking at f of x is equal to 6 over the cubed root of x. So to begin, we must simplify. F prime of x is equal to 6 over x to the 1/3. The first step that we did was looked at this rule here and applied it to the denominator. Now we have to look at this first rule here and apply that. So then we find that f prime of x is equal to 6x to the negative 1/3. So now that we have it simplified, we're ready to find the derivative. So f prime of x is equal to 6 times negative 1/3 x to the negative 1/3 minus 1, or in this case, to make it easier, we're going to do 3 over 3. Now let's simplify further. F prime of x is equal to negative 2x, since 6 times negative 1/3 is negative 2, and then negative 1/3 minus 1 is equal to negative 4/3. So the derivative of f of x is equal to 6 over cubed root of x is negative 2x to the negative 4/3. One last final note, if we want to go ahead and simplify our derivative for our last example and get rid of that negative exponent, you go ahead and do that, and we come out with negative 2 over cubed root x to the 4th as our final answer. So here I have one final example where we added all these components together. So the original function is f of x is equal to x to the 5th power plus the square root of x to the 3rd minus 9 over x to the 7th. So but to begin, we have to go ahead and simplify these two pieces of the function to make it so that we can use the power rule. So by doing that, we get x to the 5th plus x to the 3/2 minus 9x to the negative 7th. Then we go ahead and apply the power rule here. So 5x to the 5 minus 1 plus 3/2 x to the 3/2 minus 1 minus 9 times negative 7x to the negative 7th minus 1 power. Then we can go ahead and simplify that to be 5x to the 4th plus 3/2 x to the 1/2 plus 63x to the negative 8th. Now you can go ahead and leave that there, or I just went ahead and simplified the negative exponent in this last step. These two pieces of the function are the same. However, I just went ahead and made that 63 over x to the 8th. And there you have it. That's the power rule.